Okay, in this problem, we are asked to find the probability of the particle in this state, where n is the normalization constant defined here, to be in the region theta greater than 0 and less than pi over 6 radians, and phi greater than 0 and less than pi over 6 radians. So we can use the formula. Let's say we want to know the probability of the particle being between theta is theta 1, theta is theta 2. So theta is greater than theta 1 and less than theta 2. And let's say phi is greater than phi 1 and less than phi 2. That's going to equal the integration over the probability density, so the square modulus of our wave function, sine theta d theta d phi, where theta goes from theta 1 to theta 2, and phi goes from phi 1 to phi 2. Okay. Now, our state is defined piecewise, so we have to be careful when we're integrating over the density. However, you'll notice that theta only lies between 0 and pi over 6, and the non-zero part of the wave function is defined from 0 to pi over 2, so we don't really need to worry about this excess part below because it is defined outside the region that we are interested in. So we can just ignore this lower line, focus on the top line when we're calculating the probability. So the probability of measuring between, let's see, theta is 0 and pi over 6, and phi is 0 and pi over 6 is defined to be double integral 0 pi over 6, so theta 1 0 to theta 2 is pi over 6, and phi 1 is 0 to phi 2 is pi over 6. Well, in this specific region, the state is defined to be n times pi squared over 4 minus theta squared. Now, there aren't any complex terms in this, so when we take the square modulus, we're not needing to change flip any signs. There aren't any complex terms in this expression. So we will get, for the square modulus, n times pi squared over 4 minus theta squared times n times pi squared over 4 minus theta squared sine theta d theta d phi. We can collect terms here, and since n is a constant, we'll square it and we can factor it outside the integration because it's a constant. So 0 to pi over 6 on each of these integrals. And this pi squared over 4 minus theta squared term, there's two of them, so when you multiply them, we get pi squared over 4 minus theta squared, all squared, sine theta d phi. Okay. Now the theta part of the theta integral is a bit messy, so we'll save that part for next. We'll first look at the more trivial case of the phi integral. This is more trivial. We can notice that we can split the integrand up into two parts. It's separable, so we can write this as the probability of measuring between 0 pi over 6 for theta and 0 and pi over 6 for phi to be n squared times the integral 0 to pi over 6, oops, my goodness, 0 to pi over 6 of the theta term, pi squared over 4, minus theta squared, all squared, sine theta, d theta, integral 0 to pi over 6 of d phi. Well, the phi integral is trivial. We're just integrating, we're just evaluating, well, what's the antiderivative of d phi, of a constant, or 1, with respect to phi is just phi. So integral from 0 to pi over 6, 1 d phi is just phi from 0 to pi over 6. And that's just pi over 6, right? Now the other integral, the theta integral, is more tricky, but we can utilize an integral calculator to help us with this part. So we get, for the probability, theta is 0 to pi over 6, and phi is 0 to pi over 6. Pi over 6, that was our phi integral, n squared, integral from 0 to pi over 6, pi squared over 4 minus theta squared, all squared, sine theta, d theta. Now, I found that using integralcalculator.com that the integral of pi squared over 4 minus theta squared, all squared, sine theta, with respect to theta, all from 0 to pi over 6. Okay, what does that come out to be? Turns out that this integral is approximately 0.72903. Okay. And when you square out the normalization constant, you also get, or you get 0.0704. So we have all the information we need now to calculate the probability. Hence, okay, the probability of measuring between 0, theta is 0 and pi over 6, and phi is 0 and pi over 6. Okay, that was just pi over 6 n squared times this integral, which we just found to be 0.72903. So, and then multiply by that normalization constant, so pi over 6 times 0.0704 times 0.72903, and you get a result of 0.02689, which is approximately 0.0269. So, about a 3% chance of finding the particle in the given region. And this is our answer. So the probability of finding the particle between theta is 0 in pi over 6, and phi is 0 in pi over 6 is about 3%. And that is my final solution. Thank you for watching.